If we read it out of the textbook, it says using the triangle method, show graphically that a plus b is the same as b plus a, and that a minus b is the same as c or equals c, and if that's the case, then a equals b plus c. So the first thing I want to do is I want to write that stuff down, and I want to graph some vectors. So for a, I'm just going to randomly, I'm going to go corner to corner and make a random vector for a. So I'm going to start with this corner here and go to this corner here. So I'm going to come in here. Now this is my vector a. Now when it says the triangle method, what I'm really going to do is I'm going to measure the x components. So I go 1, 2, 3, 4 units in the x direction, and then 1, 2, 3 units. Oh, let's do a different color for the y direction. So this goes 1, 2, 3. So it's 3 and 4. If I separate the components. But this is the vector A, right? Is the pink one. So now I'm going to do vector B. So now for vector B, I'm just going to randomly come in here and I'm going to draw a line between those 2 points. And that one for my x components, and I've purposely drawn them kind of far away from one another. I want this, so I went over from here 1, 2, 3, 4, 5, 6 units in the x direction, and then I went 1, 2 units in the y direction. So now what I'm going to do is I'm going to do tip to tail, and then I'm going to do the triangle method. Truthfully, my resultant vector should be what? 4 plus 6 in the x direction, which is 10, and 3 plus 2 in the y direction. So I should go over 5 and go over 10 and go up 5 if I combine these, correct? So one way to do that is I'm just going to draw it out over here. I'm going to say A. Now A was, I went from here, I went over 1, 2, 3, 4, and then up 3. And that is A. Now from there, I'm going to draw B. So from B, I went over what? 1, 2, 3, 4, 5, 6, and then up 2. I'll use my little ruler here to help me out. And that's B. Now the resultant vector is tip to tail. So in other words, to draw my resultant vector, which we'll call C, I'm going to go from here to here. Now, I should have gone 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units in the x direction. And how many should I have gone in the y direction? 5. So I went up 1, 2, 3, 4, 5. So my little yellow line right there is C if I add them up. Right? Now what if I went backwards? What I wanted to show is that is the same as B plus A. So how could I do that using the triangle method? Let's do B first. So if I go and I draw B here, I'm going to go over 1, 2, 3, 4, 5, 6, and then up 2. Now, if Mr. Adams makes a little mistake, clearly that's something wrong. But when you look at the B's, doesn't this B look like this B? Yeah? And doesn't this A look almost identical to this A? They should, right? And then this is my C, which is yellow. It's kind of hard to see, but it's there. Maybe I'll use blue for C. Maybe we'll use blue for C. That might be better to see. Okay? So now what do I do? Well, this right here is going to be A plus B. And so this next one's going to be B plus A. Now, does anybody realize that I'm drawing little arrows on top of all these vectors? Do you guys know why? Because it's the notation for vectors, right? So now what I'm going to do is I'm going to go from here, I'm going to draw vector A, which means I go over 1, 2, 3, 4, and then up 1, 2, 3. So this line right here is vector A. So now where do I get the sum A plus B? I just add them up. So what I'm going to do is I go tip to tail. I'm going to go from this point to this point. And that is really B plus A. What I should write is I should write that this is B plus A. And I should probably write the same thing here. This is A plus B. Now, using the triangle method, what would I expect the dimensions for B plus A to be? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then up 1, 2, 3, 4, 5. So for A plus B, that is the same as B plus A. Do you see what I did there? And how did I do that? Well, one way I could write it is I could write that this had an x hat. So in other words, we had 5, or no, not 5. We had 10 x hat plus 5 y hat, right? That's the dimensions that we had. And what did we have for B plus A? 10 x hat plus 5 y hat. So they're the same. So that's just the first part of the equation, right? A plus B equals B plus A. Did we prove it? Was it the same? All right, now let's do the second part. Any questions on that before I move on to the second part? Now using those same, oh, hand me another piece of that graph paper. Using those same exact vectors, I'm going to do A minus B. So we said that A was over 4, 1, 2, 3, 4, and up 3, 1, 2, 3. That's my vector A. And we said that vector B was over 1, 2, 3, 4, 5, 6, and up 2. So this is vector B, and this is vector A. Now, what does negative B look like? It's the same line just going in the opposite direction. So from here I'm going to say 1, 2, 3, 4, 5, 6. Wait, I think I counted wrong. 1, 2, 3, 4, 5, 6, and then up 2. But now my arrow is going in this direction. You guys see what I did there? So to find A minus B equals C, let's do that first. So if I say A minus B equals C, what do I need to draw first? I need to draw A, so I'm going to say 1, 2, 3, 4, up 3. Now what is minus B? Minus B from here means I'm going to come down to 1, 2, and then I'm going to go over 1, 2, 3, 4, 5, 6. So this is negative B, and this is A. You guys with me so far? So now what is C? C is tip to tail. C is from here to here. So what C is it looks like I'm just going to go 2 units to the left and 1 unit up. That's my vector C, is that little orange line. So what did I say? I said that if A minus B equals C, then A is equal to B plus C. Okay, so now how do I show that? Well, I want to show B plus C. So I'm going to come over here. So this is C. And now I want to show that A is equal to B plus C. So what would be the final XY components of B plus C if they're equal to A? 4 units over and up 3. Should be the exact same thing. So the first thing I want to do is start with B. Well, B, I'm going to start here and I'm going to go over 1, 2, 3, 4, 5, 6, and then up 2. I've drawn B. Now what is C? C is, I'm just going to go over here and I'm going to go from here to here, right? That's C. This is B. Now, connecting tip to tail from here to here, shouldn't that be A? Is it? How could I verify it? This is where using the right triangle method or the triangular method comes into play. This has 1, 2, 3, 4 X components. This one goes up 1, 2, 3 Y components. This goes over 1, 2, 3, 4, goes up 1, 2, 3. Is it true? Yes. Do you see what I did there? Vector addition. Now, so when we do the vector addition and vector subtraction, really it's all the same. It's all addition when you think about it, right? It's just that I'm adding the negative or opposite vector. Well, in our two-dimensional analysis, we replace A with the velocity of a boat, and B is the velocity of the river current. And so the overall path of the boat in the current would be A plus B. And sometimes you'll have a situation where a boat's going at this angle and the river current is opposing it. So what is the overall direction of the boat? C. Does that make sense? Okay, good.